In internal combustion engines, we often talk about three operating conditions: full load, partial load, and no load. Full load means the engine is producing the maximum power it can deliver under a given condition. In simple words, the engine is working at its highest capacity. This happens when the driver asks for maximum performance, such as during hard acceleration, climbing a steep hill, or carrying a heavy vehicle load. In a gasoline engine, the throttle is opened wide, allowing more air and fuel into the cylinders. In a diesel engine, more fuel is injected while air intake is usually not throttled in the same way. In a CNG engine, the engine also works under full load when it delivers the maximum power possible, although the actual output can be slightly lower than an equivalent gasoline engine because the gaseous fuel takes up some intake volume. And partial load, the engine is working but not at its maximum power. This is the most common condition in everyday driving. For example, when a car moves at a steady speed on a flat road, or when the load demand is moderate, the engine operates under partial load. In this case, the engine produces only the amount of power needed to match the demand. Fuel consumption is lower than in full load, and the engine is under less stress. This condition applies to gasoline, diesel, and CNG engines alike. And no load means the engine is running, but it is not driving any significant external load. The engine still consumes fuel because it must overcome internal friction, pumping losses, and auxiliary systems, but the useful output power is very small. A common example is when a vehicle engine is idling, or when a generator is running without powering any electrical devices. In all engine types, gasoline, diesel, and CNG, no load operation means the engine is on, but almost all the energy is spent just keeping the engine itself running. So in summary, full load is equal maximum power output, partial load is equal reduced power output, normal everyday operation, and no load is equal engine running with almost no external demand. The basic concept is the same for gasoline, diesel, and CNG engines, but the way fuel and air are controlled is different in each one. Okay. Let's continue with the calculation of engine load. At first, we have aerodynamic drag. The way to calculate an engine load varies depending on its application. In this section, the calculation reviews that a vehicle engine. For a vehicle moving at a constant velocity, the load comprises of forces from aerodynamic drag, rolling resistance, a road gradient. Usually engineers refer to the engine load of a vehicle as its road load. So aerodynamic drag. Generally, vehicles expend the majority of their energy in overcoming aerodynamic drag. Moreover, designers minimize the level of drag on a vehicle by making it narrower, shorter, and with a more slippery shape. Also, driving at a slower speed reduces the drag on a car. The force on a vehicle due to drag FD is a function of air density. The vehicle's frontal area, A, and the relative velocity with the wind, V, and the drag coefficient of a vehicle, C under D, which depends on its shape, and rolling resistance. Another factor that contributes to the force that the vehicle's engine has to overcome is rolling resistance. This rolling resistance F is equal, actually depends on the total mass of vehicle and its constituents, M, gravitational acceleration, G, and the coefficient of rolling resistance, C under R, which the type of tires and road surface influence. And road gradient, the engine load of a vehicle when moving along a slope is different from when it is moving on a flat surface. Furthermore, the effect of driving on a slope contributes to the engine power when moving downward, while it adds to the load when driving upwards. Thus, the effect of the road gradient on the load comes into consideration only when driving uphill. The force on the car due to road gradient, G, it depends on the angle of the slope and the car weight. So, combining these three factors together, the total road load, if a total of that an engine has to overcome is given as summation of them. Okay. And horsepower, the relationship between the capacity of an engine in horsepower, the engine speed in RPM, and the engine's torque is as follows, as you can see. Actually, engine loaded idling means for an automobile refers to when a vehicle is not in motion, but the engine is still running. Usually this occurs in traffic or when the driver is waiting while gear is in park. So, in this video, we explained how engine load works in gasoline engines, diesel engines, and CNG engines. And you understood what full load means, what partial load means, what no load operation means, and how these conditions affect engine power, fuel consumption, and performance. If you found this video helpful, please like, comment, and subscribe for more engine and automotive learning content.